Okay, so a very good morning to all of you. Am I audible to all of you?
Yes, sir. Good morning.
Yeah, good morning. So in the previous class, we have concluded that the formula of calculating the time delay when it is used by, when it is generated by the timers that is available in the 8051 microcontroller. So here we will see that how this mode 2 and mode 3 operation can be done. So this thing also we have discussed in the earlier class. Just look into the delay part. You can see this is the delay part. So in this delay part, there is no inclusion of TH. Okay. So TH is not required for calculation of time delay by using this mode 2. Okay, because as we know that the value loaded into TH, that is automatically loaded to TL after the overflow of the previous count that was done by the TL register or the timer low part. Okay, and similarly in not similarly actually, uh, in mode 3, we can see that TL0 and TH0, that means timer 0 is only used for the timing purpose, timing or timer or counter purpose. So whenever TL0 is used, so TL0 is used as the timer 0 and TH0 is used as the timer 1. Why, sir? Because you can see when this particular TF0 and TF1, that is the timer overflow bit of timer 0, this TL0 register, when this is overflown, then TF0 is set. So this TF0 is related to timer 0. So whenever this TL0 is used for the timing purpose, so in mode 3, this will be automatically treated as timer 0, and in case of TH0, this will be considered as the timer 1. Clear or not? This is a constructional and manufacturer given specifications, so we cannot change this. Okay, so we are going forward that mode 2 programming, 8-bit timer, range is 002 FFH to be loaded into the timer register TH. So as we have said, these things are written. I'll share this material with you. There you can go through it. Okay. Now these are some steps has given 1 to 5 mode 2 programming steps. Okay, and an example is given. Okay, so in the example you can see that move tmod is loaded by 20h. So can you tell me which particular mode and uh, which particular mode is used here? Can anyone tell? Am I audible?
Sir, mode 2.
Mode 2. That is the thing. I have it is written over here, but still you are not responding. So here, tmod is loaded by 20h and move th1, that is 5h. Okay, and set bit tr1. That means if we go backward, just see that timer 1 is taken. Okay, and in this timer 1, just see this th is loaded by 05h. Okay, and there is no mention of TL. Look, we need not to initiate, we need not to load a value into the TL. Okay, so this 05h is automatically loaded to TL and it will count up to FF. Then again this timer overflow flag is set, then automatically load the 05h to TL, and this thing continues. So here in the program you can see, so TF1, that is the timer overflow flag for timer 1, that is continuously checked that whether it is set or not. by this JNB TF1 instruction. Okay, so if it is not set, then this particular loop repeats. Clear? And when this bit is set, so this condition is not satisfied, then come to the next instruction, that is CPL P1.0. Okay, now this is the again this is the case of this those LED blinking thing, whatever we have discussed discussed in the earlier portion, that was in delay generated by the registers. Okay, you can remember. So this CLR TF1, that is, we need to clear this thing, this particular overflow flag, and sjump back. So this is the end. Okay, so there is a problem given: find the frequency of the square wave generated on pin 1.0 and the smallest frequency achievable in this program. Okay, so you can do it by your own, because you need you know that how the calculation is done. Okay, now these are some examples that is required to know that when a program, when a delay is to be generated by mode 0 or mode 1 or mode 2 or mode 3, now how the programming can be done. Okay, so here you can see that the solution is given as this. So these are some examples given, so I'm not getting into it. You can just put the formula and take the values of TL0 and TH0. Okay, and you will get the result also, and you can verify with this particular answer. Okay, so again, this is the same thing, some examples. Now the counters. Okay, now whatever we have discussed, that is that was the timer operation. So as we have we have discussed that the any external events, that is the counting operation. Okay, so whenever this C oblique T bar equals to 1, that means counter operation is there. So C oblique T bar is situated in the T mod register. So T mod register, this C oblique T bar is, if it is set by 1, then the timer will act as a counter. Okay, now external, that means you can remember in the pin diagram of 8051 that there were two pins, that is T0 and T1, and this was the special functions of port 3. So these two T0 and T1, if we use this counter 0 to count some external event, then from T0 through T0 pin the external pulses comes. Okay, and in case of if we use counter 1, then through T1 the external pulses come. Clear? So another example is there. So assuming the clock pulses are fed into pin T1, write a program for counter 1 in mode 2 to count the pulses and display the state of the TL1 count on P2. Okay, so the from T1 the pulse is coming. Okay, and TL1 state is to be shown into the P port 2. Okay, so this is the objective of our program. So we have loaded the value of 0110. That means I'm just annotating over here. You can see this is the thing is used for the T1. Okay, so 0110, that means C oblique T bar. This is the C oblique T bar. If you can remember the construction of T mod register, that is 1. So the counter operation, and 10 is mode 2. Okay, that means 8-bit auto reload mode, and TH0 is loaded by 00. TH1 is loaded by 00, and set bit P3.5. Now what is P3.5? You can see to to by default any pin is set as the output pin. To make it input, so we need to set by 1. So we have in the program it is mentioned that external clock pulses will come into the microcontroller through pin T1. So T1 pin is the P3.5. Okay, so we need to set bit this P3.5 and set bit TR1. This is required to run the timer run control bit. So TR1 means for timer 1, and whatever the value there is in the TL1, that is moved to the accumulator, and from accumulator it is going to P2. Okay, and now it will check that from 00 whatever is there in the TH1, as it is in the mode 2, so this automatically this TH1 value will be loaded to TL1, and then the TF1 bit is checked continuously that whether it is set or not. So unless it is set to 1, that means the counting is not completed. So it will go back to this, okay, this location, and this loop continues continuously. Okay, this back loop, this part continues until this TF1 is set. When this TF1 is set, then this condition is not satisfied. So come to the next instruction, that is CLR TR1. That means clear the timer run control bit 1. Okay, and then CLR TF1. That means we need to deactivate, I mean we need to reset the value of TF1, that is the timer overflow bit, and we need to stop the time counting. Okay, so TR1, when it is stopped, then the timer will not act. Okay, so just go back to this one. You can see in the mode 2, if this bit is 0, then it will not be there. If this bit is 1, then output will be there, just like this. Okay, so any questions?
So,
Yeah.
so just repeat the loop back and again.
Now, just a minute. Yeah. So I am focusing on this particular loop. Okay. Now see that TH1 is loaded by 00H. So by default, this in mode 2, this 00 is loaded to this TL1 also. Okay, this TL1 also. So first the count is 00H. So this 00H is given to A register, that is the accumulator, and move P2 comma A. That means our objective was display the state of the TL1 count on P2. So TL1 count is 00H. So that is transferred to P2. Okay. Now TF1 is set. It is set. No. Okay. So this condition is satisfied. So again go back to this one. Okay. So by this time another pulse come. Then TL1 value is increased. So that is 01. Okay, and then this 01 value is sent to P2. Again TF1 check that if the counting operation ended. No, this is not set. This is again 0. Then again back to this loop. So it again incremented by 1. So it is 02. Then this 02 is sent to port 2. Okay, and this thing continues till FFH. Okay, this loop will continue until the value of TL1 reaches FFH. When it is FFH is there, so this timer 1 indicates that my counting is completed. Clear? Clear or not?
यस सर, TF1 फिर ओवरफ्लो फ्लैग
सेट हो जाएगा.
टाइमर 1 का सेट हो जाएगा. ओके
Right.
सर.
Everyone understood? Rajkumar understood?
Yes, sir.
Okay, so we are moving forward. Now this is the same thing that was already discussed in the timer section. So again, this timer will be just substituted by the counter. Just this one. Okay. So we are going forward. Now this is a beautiful example. Whatever we have done in this program, just in this program is just repeated here. You can see counter 1 mode 2 is selected. Okay, so same value is loaded to this particular tmod register, and th1 is loaded by 00. Okay, and set bit 3p 3.5, that is p make t1 input. So by default t1 is set by output. Every pin in the microcontroller is set as the output. Okay, so by to make it as the input port, we need to set by 1. So it is set bit tier 1, that means the start the counter, then move a comma TL1, just repeat those things, display on port 2. Now now what is the use of LEDs? Now use of the LEDs is, suppose it is counting 0 2. Okay, this is 0 2. So if it is converted into binary form, so it will come like 0 0 0 0 0 0 1 0. Clear? So if it is fed to this particular pin, so what will be there? So this pin will be glown. So if the LED is connected with this pin, this LED will glow. All the other LEDs will be off. Clear or not?
समझ गए सर.
Yes, sir, clear.
Yes
Okay.
sir, clear.
So we will if the physical class opens, I don't know when it will be started. No one knows, because there is no certain guidelines from the government as well. So if we can meet in the college, then we can see that how this thing works. So we can do some hands-on also. So by using this 8051 microcontroller, that how the LEDs can be changed. I mean the condition can be changed. So in the next count, it will be 03. Okay, so this will be like we are removing this. So this will be 1 1. So this LED and this LED will glow. Understood? And so on. So whenever all the LEDs glows, then we can see that it will be FFH. Clear?
Yes, sir, clear.
Okay. So we are going forward. Now this is the very, very interesting thing in the 8051 microcontroller, that unlike the 8085 microprocessor, this 8051 microcontroller has a capability of communicating without a peripheral device. Just remember, there was a block in the block diagram of 8051 microcontroller named as UART, that is the Universal Asynchronous Receiver Transmitter. So this block can act as the receiver as well as the transmitter. Okay, so how the transmission works, we will see that how the transmission works. Now there are some points to be discussed. You can see that the serial communication is used for the transferring data between two systems located at distances of feet to millions of miles apart. data must be converted in serial bits. To send data using parallel in serial out register, we will discuss everything. To receive data using serial in parallel out register, protocol has to be maintained between sender and receiver. Okay. Now we are discussing that there are two types of communication: serial communication, that is synchronous and asynchronous. So synchronous is the transfer of block of data, and asynchronous transfer a single byte at a time. Okay. So here in 8051, the serial communication. So there are serial communication and parallel communication. Can anyone tell that what is serial communication and what is parallel communication? What is the difference between this serial communication and parallel communication? Yeah, tell me.
Sir, in serial communication, if one person is communicating, other person has to stop. In parallel communication, several persons can talk simultaneously.
Okay. So in some easier words, if we take an example, okay. So suppose you and your 4 friends, so total of 5 friends, wants to go for a picnic. This is a picnic time. So you want to be you want to go to a picnic. You want to attend a picnic. So suppose the bus came. By using this bus, you need to go to the picnic spot. Okay. So what will happen? The bus has a single door. So you people will do what? You will stand one by one in a queue, and one by one you will go into the bus, right? So this is the serial communication. Okay. Now what is parallel? Suppose if the bus has a 5 different entry points and you people are going inside the bus through those 5 entry points. So this is the parallel communication. So what is the advantage and disadvantage of these two? Can you tell me by using this example, what is the advantage of parallel communication?
Sir, in serial
The
communication,
time delay कम होगा sir.
Yes, that is the thing. So Raju, what was you telling? What are you telling?
Sir, I was telling that in serial communication, less bandwidth is required, and if parallel communication, more bandwidth is required.
Yes, both are correct, Aditya and Raj. So the basic difference is in parallel communication, the communication is faster. Okay, because parallelly every information is conveyed to the receiver, from the sender to the receiver. But in case of parallel communication, in case of serial communication, you need to wait unless till the previous bit is transferred or transmitted and received successfully. But in case of parallel communication, again, the bandwidth required for this particular parallel communication is much higher than that of the serial communication. Okay. So this is the basic difference between the serial communication and parallel communication. So in case of 8051, only serial communication is there. Okay. Now, if we can focus on these 3 and 4 points, point number 3 and point number 4, to send data using parallel in serial out register. Okay. So you can remember there was a special function register SBUF, serial buffer. So this SBUF register is used for the transmission and reception of this particular serial communication data. So in the transmitter side or the sender side, there is a data of, I mean, there is a SBUF register, and in the receiver side, there also a SBUF register will be there. So two SBUF registers, one in the receiver side, one in the transmitting side or the sending side. So to send data by using this parallel in serial out register, that means whatever the transfer of data we have learned inside the microcontroller using those instructions, move instructions. So these datas are moved parallelly. Okay. But in case of serial communication, so if the SBUF register is there, suppose in the figure, just a minute, in the figure you can see there are, I'm just pointing out, there are 8 bits. Okay, so there are 8 bits. So SBUF is the 8-bit register. So this data, suppose this data is stored into the SBUF register. Okay, so what is there? 0 1 0 0 0 0 0 1. So whenever the particular SBUF register is storing the value of this particular bit pattern, when and suppose this is the sender side, this is the transmitter side. So what happens during the transmission or the serial communication? Now at first this particular 1 bit is transferred. Okay, then 0, then 0, then 0, then 0 0 1 0. Okay, like this way, like this, the bits are transferred. Okay, and in the receiver side, first this 1 will be received and stored into the SBUF register. Then 0 0 0, जैसे जैसे ये send करता जाएगा, then from the right hand side to the left hand side, those bits will be stored serially. Clear or not?
Yes, sir, clear.
Yes.
Okay. Now अगर हम लोग देखेंगे, then we cannot send this particular data by using this particular, just a minute. So we cannot transfer the data. बस ऐसे ही हम लोग कुछ data transfer नहीं कर सकते. So there are some protocols, just that is mentioned in the point number 5. Protocol has to be maintained between sender and receiver. So what is there? So अगर तुम लोग रास्ते में निकलते हो and if you face a signal, then what you will do? You will wait for the signal to be read for the vehicles, and say at the same time you will look for the signal for the pedestrians to cross the road to signal the signal turns green. Okay, तब तक wait करोगे, and whenever these two conditions satisfied, then you will cross the road. Okay, similarly these particular datas also, whenever it is to be transmitted, then it looks for the availability of the channel, whether it is a wired communication or wireless communication, it looks the availability of the channel, and if it is there, and if it is the channel is available, and the receiver is ready to receive. ठीक है, जैसे कि अगर तुम रेडी नहीं हो, ठीक है, हम तुम्हारे पास एक मानो कि हम लोग एक कुछ भी एक चीज सामान तुम्हें दे रहे हैं, ठीक है, बाय हैंड्स. तो इफ यू आर और सपोज आई एम सेंडिंग अ लेटर टू यू and you are not at the home, so you are the receiver, I am the sender. If I am telling that okay, you be at the home because I am sending something and you will receive it, so I am confirming that the receiver is there. But if I not if I won't let you know that I am sending this something to your home, then it may be there it may be there that you are not at home, so the letter or the parcel will not be received by you and it will get back to me, so the time is lost. So this is the thing which we need to keep in mind, that before sending we need to take the availability of the sender of the receiver as well as the channel. Clear? So whenever this marked signal is there, that means the receiver is ready and channel is available. Okay, and start bit, it sends the start bit. Okay, particularly this is sent by the sender, and at the receiver side, when this start bit is received, then the receiver microcontroller understood that इसके बाद जो डेटा आएगा that is the particular data. ठीक है, ये start bit है, that indicates the receiver that after this whatever comes, that is the information. Clear? So the receiver understood that after this this particular data will be started. Okay, so from D0 to D7 is transmitted as we have discussed, just serially, and end of this 8-bit data, the receiver have to understand that this is the end of the data. After this some new data will come, so another stop bit is given to the receiver. When this stop bit is given to the receiver, the data transmission is end. Clear? Now the receiver will do what? This data is stored, this particular information is stored into the SBUF register, and this SBUF register transfers the data to its equivalent, whatever the required target location, whether it is some registers, whether it is some accumulator or other special function register, we need not to think about it, because it is the function of the objective of the particular receiver microcontroller. Okay, understood? Okay, so there is another thing, there is a data transfer rate. The rate of data transfer in serial communication is stated in BPS. Do you know that what is BPS?
Bits per second.
Yes, bits per second. So now we are counting as GBPS, or in somewhere in MBPS. So we will see that what are these things, what is BPS, what is KBPS, MBPS and GBPS. We will see that how this particular transmission is done. Okay, but unfortunately there is a constructional material constructional complexity is there, so 8051 cannot transmit in KBPS also. Okay, so it will be in BPS. So we will see some data transmission things, how these things works, okay, in the subsequent classes. So this is for today. I'm just stop sharing. So if you are having any questions, you can ask by the time.
So, sir, repeat the role of stop bit and space.
So start bit, that means मान लो कि हम तुम्हें घर पे 8 पार्सल भेजेंगे, ठीक है। तो हम तुम्हें बताते हैं कि जब तक हम नहीं बोलेंगे कि तुम दरवाजा बंद करो, तब तक तुम दरवाजा नहीं बंद करोगे, ठीक है। तो क्या करते हो? तो हम बताए कि अभी हम भेज दिए, पहला वाला जो है वो पहुंच गया। So this word is the start bit, that you are the receiver, I am the sender, and I am letting you know that you have to receive, I mean you are about to receive the information or the required thing you want, okay, from now onwards. And after the transmission, I will let you know that हाँ मेरा हो गया, अभी तुम दरवाजा बंद कर सकते हो, right? So this is the stop bit, okay. So this is the difference between I mean this is the function of the start bit and the stop bit. So just record this. So without the start bit and stop bit, the receiver will not be aware that whether the particular information is coming or the sender has completed the transmission or not. Okay.
Okay, sir.
Any other questions from anyone? Okay, so after recording your attendance, you can leave the class, and I'll share a assignment soon. So you have to submit this, okay, in the LMS. Okay, so I'm ending the class. Thank you. Thank you so much.
Thank you, sir.
Thank you, sir.